Ladies and gentlemen, boys and girls, children of all ages, as I'm walking around, I'm seeing much difficulty on the first problem. So we're going to, or is it the first problem? Yeah. Problema numero uno. I didn't write it word for word up here because I didn't have my paper in front of me and I was just summarizing it. So basically this problem says there's a school district, un distrito, and it has 4,104 students. Is that the right number? 4,104 students. That's how many there are. There are 4,104 students. No more than 4,104 students. And we're putting those students into 6 classrooms. Or to 6 schools. Sorry. We're putting those students into 6 schools. We're listening so we know what we're doing. So if I have 4,000 and I'm saying you go to school 1. You go to school 2. You go to school 3. You go to school 4. And then this one 5 and this one 6. And I start over. Is each school going to have more than or less than 4,104 students? Less. Now the 2 operations we know how right now to make something less is either subtraction or division. If I subtract 6 from this, I'm going to get 4,098. Is that right? I'm going to get 4,098. Does it seem like that would be the amount in each school since we start with 4,104? No. So subtraction's not the way I'm going to do it. Division's obviously the way I'm going to have to do it. Now I see lots of panicked looks. I can't divide. If you can multiply by 1-digit numbers, you can divide. Prove it. Okay, I will. Okay? So we have 4,104 divided by 6. Now dividing by a 1-digit number is real easy. But the process I can teach you how to divide by a million-digit number is even easier. I can take my divisor and I'm going to make a list. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. And 6 times 9 is 54. Now the reason I do that, if my divisor was 312, all I have to do is list my multiples of 312. You can all do 312 by 1, 312 by 2, 312 by 3. You can all do that. So if you can do your 1 through 9, you can divide. What many of you looked at, figured out was a division problem and didn't do anything but write down a number like 800 or something crazy like that. Okay, now I know these. I have to go through and I ask myself, does 6 go into 4? No. I am not going to have a number above the 4. I'm not. Does 6 go into 41? Yes, because 41 is greater than 6. That means I'm going to have a number in the hundreds place, a number above the tens place, and a number above the ones place. That tells me my answer must be a 3-digit number. Now, if we use any common sense whatsoever, we know that it's not going to be a remainder, because I'm not going to take one student and divide them into 6 different schools. Here, your 2 arms go that way, your 2 legs go over here, your ears are over there. That doesn't make any sense. So obviously when they wrote this problem, they figured out it's going to have to go in equally, so there won't be a remainder. Now I see, and if you work with me, this division is going to be easy. I see I'm taking 6 into 41, because it doesn't go into 4, so it has to go into 41. I come back here and I look at my list. I'm looking at my products, and I want to see how close to 41 I can get. Well, I have 6, 12, without going over. 6, 12, 18, 24, 30, 36, 42. 42 is too big. So I'm going to have to go back and use 6. 6 times 6 is 36. That means my 6 in my hundredths place. Then I multiply 6 times 6. I get 36. And then I subtract 41 minus 36, which, if I'm doing my math right, is 5. Is that right? Yeah, 5. And then I bring down my 0. Same process I just did. I need to get as close to 50 as I can without going over. I've done all the difficult work. I've listed my multiples. So I go through my multiples, I find as close to 50 as I can get without going over, and it's what? 48. So what? 6 times what gives me 48?
6 times 8.
6 times 8. That's going to be in my tens place. 6 times 8 is 48. That's what I'm subtracting. And 50 subtract 48 gives me a 2. Then I bring down my 4. This is my ones place. I've already said I have a 3-digit answer. It is very, very important that you put the numbers directly above whatever place value it needs to be. Whatever place value it needs to be. Now I have my 6 into 24. I go over here, I want to get as close to 24 as I can get without going over, and what do I get?
6 times 24.
6 times 4, I get 24. And I subtract, and I get 0. So I don't have to split one kid into 4,000 places. I want to check it. The same thing. You should always want to get your work right. And I'm sure you always want to get your work right. But you should try to get your work right. Which means I could check this and multiply 684 by 6. Because that's the inverse operation. The inverse of division is multiplication. And if I did this math and I did everything correct, I should get 4,104. But I'm going to say it again. I'm probably going to say it another 30 times this year. If you know your one-digit multiplication facts, you can divide no matter how big the number is. If you know your one-digit multiplication facts, you can multiply no matter how big the number is. Because you're always only doing one digit at a time. And we'll continue working with this so you don't have to panic. But did you hear how I talked my way through it? Did you see how my first step was to list all my multiples of my divisor? I listed my multiples. Multiples 6, 12, 18, 24, 30, 36, 42, 48, 54. Those are multiples. I listed the multiples. Now, if my divisor was 57, I would have to work it out, obviously. 57, 114, and then keep going. I'm not going to go farther than that because that'd be cray-cray. Something with a 1 in the ones place. List your multiples. If you miss a division problem, I'm going to make you go back and list your multiples anyway. So you might as well do it so you get it right the first time. Boom, shakalaka, peace out, God bless, love you, do some kind today. Save the bees, please subscribe.